Hi everybody, Professor Chance here. Today we're going to take on a very serious topic, and that is climate change. Fact or fiction? If it is real, what is it all about? Why is it happening? Are we involved? What can we do about it? We'll answer all those questions and more in a couple of seconds, so come on back. Hi everybody, welcome back. Today on the show we're going to talk about climate change. Is it fact or is it fiction? Well, we see things going on around us and we wonder what's happening. I think a lot of us have taken climate change and used a misnomer and call it global warming. And yes, indeed, the atmosphere and the earth is getting warmer, but we brush it off when winter rolls around and we say, well, the temperatures are down in 20s or in the teens or below, and say, what's wrong? What's happened to that global warming? Well, we'll talk about what climate change really means. It's a lot more serious than just global warming. So I was looking back as I was preparing to do this show. I was looking back on some stuff I'd written a little while ago. This was in 2008. I was writing a blog called Planet Earth Exploration or Extinction, making the case of whether or not we should be exploring other planets for potential colonization. But in that, to start the argument, I would say, or I said, what were the top 5 extinction level threats that we have to our planet? And interestingly enough, number 1, I had global climate change, and number 2 was global pandemic. And then geological upheaval, meteor asteroid strike, thermonuclear exchange. There's even been some talk about supervolcanoes, but that wasn't on this list. But these 2 are things that are staring us in the face right now. And I think that that's very, very interesting. So what is this all about? Well, here's our planet, planet Earth, and our main energy source, or primary energy source, is the sun. The sun has consistently been radiating its energy to us and other bodies within our solar system for millions of years. And the energy density of solar radiation in our upper atmosphere is just about 1,368 watts per square centimeter. And that's a surface measure. And as you go further down, it gets a little less. Down in our atmosphere, the part that controls our climate, it's about 1,000 watts per square centimeter all the time, every day. It's always doing this. Now, so our atmosphere is broken up into different levels. Down closest to the surface is the troposphere. Stratosphere is next, the mesosphere, thermosphere, and these are the different measurements in miles of where it happens. About 300 miles is what's understood to be outer space. But you know, this gradually and uniformly tapers off. The atmosphere thins out as you go higher. The Kármán line, which most understand to be the line between our atmosphere and space, is about 62 miles. Now, our atmosphere is made up of nitrogen, which is 78%. Now, we all think that oxygen is the most important thing we have, but nitrogen is an inert gas, but oxygen is 21%. Argon only 0.93%, carbon dioxide 0.04%. And we're going to come back to carbon dioxide. And then there's trace amounts of these other gases as well. And that's what we breathe in every day. That's what causes our climate to be what it is based upon this mixture of chemicals and an energy source from the outside. And many of you who know chemistry will understand that chemical reactions occur with heat and mixture of the right elements. Now, what you're looking at here in the yellow is the total solar radiance, and again in watts per square centimeter, over the years. This goes all the way back to 1888 till the present. And as you can see, it hasn't varied much from this 1,300 or so watts per square centimeter over the last 140 years, okay? But the average temperature, surface temperature of the Earth has been going up in rather dramatic fashion since, let's look at 1980. And it's continuously going up, and we continue to make records of our average surface temperature on Earth. We continue to make records of that each year. And scientists are concerned about this. Why? Well, what has changed? Because if the sun has been doing the same thing and the Earth itself has not changed, what has changed? Well, first of all, as I stated, our climate, as you can see below in the troposphere, is energized by the sun and the mixture of gases that are below. And as you can see in the video, you'll see that the movement of the Earth and the climate. Well, what as far as movement is concerned, these jet streams move our atmosphere around the planet. So, you know, you're familiar with the polar jet stream, subtropical jet stream, but this is what keeps our climate changing. Our weather patterns, I should say, is changing because of the movement, and this too is powered by the sun and by pressure levels, and of course gravity and everything else that's made up of this system that we call our planet Earth. Now, let's talk about the radiation that comes in, because this is the important part. Why? Because energy is equal to Planck's constant times the frequency. And so in this case, infrared energy from the sun, which the sun is made up of various energies, as you can see in its spectrum. You can see different types of wavelengths of light that makes up the spectrum of solar radiation on Earth. And this is the light that we see, but these energies out here are all part of what makes up the sun's radiation. Now, interestingly, right here, at this frequency in the high infrared, carbon dioxide is in the absorption band, and it absorbs that energy, holds it, traps it, and that is part of the problem. So if you go back here and see that you have light coming in, but these greenhouse gases, which carbon dioxide is one of those, traps this energy, this heat, and this is responsible. So that must mean that these gases must be increasing in their number in order to trap this energy and cause our temperature to rise, because the sun hasn't changed. It continues to give you this spectrum. So, what are these greenhouse emissions? Well, the largest component of all our greenhouse gases are carbon dioxide, and that's 81% of the greenhouse gas emissions. Methane is another, nitrous oxide and other fluorinated gases. But what are the things that make up, what are the culprits? What are the culprits for the production of these gases? Well, agriculture and land are the highest. Well, no, let me go back. The highest are the electricity and heat production. Okay, that's something we're doing. Agriculture and land at 20%, then industry, transportation, other energy productions, food and waste, and then building projects. Buildings also that emit things because they're there and they're operating, they're being heated or what have you, right? And there's many, many buildings around the world, and this is responsible. Here, this is the culprit. Now, I would argue that almost everything on this listing, on this group, is affected by human beings. So here you see over 400,000 years going back, here's the CO2 production. And it goes up and down and up and down. This is garnered or gathered by measuring ice and other than the fossil record. But you can tell the density of the CO2 in the atmosphere. But look way out here at 0 year, which is now. From 1950, look at the spike that has occurred because of something. And again, this is the advent of the industrial age and the age of technology. Okay, let's take another look at some data. And this is the population. Look at the population from the 1700s up until now, and this is projected over into 2100 if we make it that far. But here in 2020, we're 2019, 2020, we're right around 7.7 billion people on the earth. But look at the continuous exponential growth of the population on earth. Now, what are we doing? We are utilizing energy. We're producing food. We're producing waste. We're doing a lot, and we're doing it in exponential numbers because we must accommodate our living capabilities, our living, the way we live. We have to accommodate that lifestyle through what we do. And just imagine, even as temperatures rise, we have to do more to cool ourselves, which creates more of these greenhouse gases. So it becomes a vicious cycle if we don't get off the train. Here are the land and ocean temperatures. Again, and this is all just making the case that somewhere from 1950 on, we have seen the temperatures grow. And there's nothing else we can point to but the advent of our technology and our industrial and technological processes that can be responsible for what has happened over this short period of time. So, what's the impact? Well, let's take a look. This is ripped right off of the headlines. We have fires that are burning. Well, because there's a drying out effect because of the temperatures, that forest fires can certainly begin and grow and spread under these conditions in certain areas. Whereas in other areas, you see storms that are greater in number, storms that are greater in strength than what we've ever seen. Each year becomes more intense than the other. What are we seeing here? Droughts, and many, many other things. So let's talk about that. What are some of the impacts? Well, temperatures will continue to rise. And, we're seeing cities now that are seeing 120 degrees regularly now. That's an uncomfortable prospect as that continues to go up. Frost-free seasons could lengthen, meaning that you don't see much frost and cold in areas, which is part of what we need in our ecosystem. Changes in our precipitation patterns, rains, where you may see floods in some places, intense droughts in others, where these patterns kind of culminate into pockets as opposed to being equally spread as to what we might be more used to. More droughts and heat waves. Hurricanes will become more frequent and more intense. We're seeing that now. We're living that now. Where I am right now, we have a tropical storm warning, and we're concerned about that even as we speak. Sea levels rising, and this one is pretty dramatic here. And resources continue to be expended to meet all of these issues that continue to grow. Now, here's something having to do with the sea levels rising. This is the population density of the United States. And this is the population of people that live near a coastal area. So 92 million people in the United States as of 2019 lived in a coastal region. And if you want to see this graphically, take a look at this. You have population all on these coastal areas, all around here. People tend to live around water areas. And some of our largest cities, Miami's down here. You have New York and all of New Jersey, Washington, D.C. over on here, California. All of these, even parts of Texas, the bigger cities in Texas are not too far away from the coast. And if sea levels rise, those cities will be inhabitable. So let that sink in. Now, what can we do? Is it too late? Well, let's think about a few things. Because remember, it is the continuous growth in the amount density of the greenhouse gases in our atmosphere that is causing this heat to be trapped. And the heat being trapped is the energy that's driving the system to do different things than what we've been used to. So if we can reduce or limit those things, then we have a chance. So, number one, we could reduce automobile emissions. Now, I'm not saying everybody jump on bicycles and go everywhere, but that wouldn't be a bad idea. But also, use public transportation, carpool, use vehicles that are less intense in their use of fossil fuels, or they're more economical. Work together, see? But if you look at this here, and this is just an example, but everybody feels they have the right to have a vehicle, and they do. But collectively, there is an impact. And we have to understand that we all live in this place together. Here's another item. We could utilize clean and renewable energy resources. As you can see here, we're burning some sort of material that puts these gases into the atmosphere on a continuous 24-hour basis. And what we're getting out is energy to do what it is we do. The same thing can be done with solar panels. However, the efficiency and the cost. The efficiency needs to go up and the cost needs to go down in order to make this something more practical. But those things happen when more people use it because the technology drives innovation. And the use of the technology, I should say, drives the innovation that is required to maintain it, and that's a business issue. Well, another thing is to do something about them. As you might remember from the pie chart I showed you, 10% of the gases, greenhouse gases, are methane, and these are the biggest culprits in the production of methane, besides ourselves. And you know where it comes from. But so I don't know what to say. I mean, you know, some people say, well, reduce eating meat, but it is a contributor. We've got to make some decisions on whether the hamburgers are more important than our health and safety on this planet. You decide. Another thing, vote. And the reason I say this is because our political leaders are making decisions about what we would do or won't do about this issue of climate change, what we can participate as a country ourselves and also around the world. But we certainly have an impact on this in the United States as well as all other countries around the world, and we have our part to do, but we need leaders who recognize this and understand this, and the only way we can make sure that we do is to vote in that direction. Okay, so what's the conclusions that we can draw here? Well, climate change is real, and it is affected by human beings. More energy is trapped in our ecosphere than responsible, and it's responsible for the changes that we see. So there's more energy here. It's churning the system up. It's making the changes. But it's not too late. It's not too late. We can do something. Now, another thing is that we can look around us in our solar system. There are plenty of planets out there that have, deadly and inhospitable environments that may have been different in the past. And we don't want our planet to go in that direction. So the solar system can sustain inhospitable planets, and it'll just go on and be whatever it is, whether we're on this planet or not. The solar system and the universe won't care. So it's up to us to make the difference and to make the changes that we need to. But there are things that we can do right now. Here's some of the sources that I've used. I'll take these, I'll post them in the comments so you can pull them up yourselves and see there's a lot of interesting information that's there to be learned about this. It's a ton of information. But look, this is our planet. This is the only one we have. This is our home. We live on it together. And we've got to do something, and we've got to take the responsibility for what happens here and how we live here. And it truly is up to us. So, let's keep thinking. Oh, hi everybody, this is Chance Glenn. Thank you for watching the show. I hope I've given you something to think about. I want you to continue to support us and follow us. First of all, you probably see this show on YouTube, so be ready to follow it and keep up with every post that we make. We're also up on Facebook under Something to Think About. Our webpage is under the Morning Bird Foundation at morningbirdfoundation.org, and you should be able to find the show there. Also, you can email us, you can post on Facebook, got a Twitter account as well. So you can communicate with us. I'll be periodically answering questions from you, So look out for that. But continue to just help us out. You can like and subscribe. That goes a long way to doing that. But most of all, we want you to keep thinking. We want you to give you something to think about. Take care.